All right, what's going on, guys? So for part two of the series, we're going to be following up with some of the TLDR and the introduction I gave the last presentation. So this one, we're actually going to get into the sort of the problem definition, exactly what sort of data set we'll be using for this presentation in this tutorial. So I'll go everything line per line so that we have an understanding of exactly why we're importing everything and why things are there. That's very important, right? You're not just importing things because I tell you to. You're importing it because you understand how these, the reason why these things work. So let's just start with the import. So we're importing the OS package. What this does is just it's changing our current environment path to the current working directory of our main.ipython notebook. What that means, the reason why we do that is because we'll be developing the class in utilities.py, and because it's in the same folder, when we change the current directory, we can actually import it as import utils. And then we run this, it'll import utilities library, and then there you go. We don't have to go looking for it because it's in the current working directory. This area just has to do with my Tensorflow version. I actually haven't installed TensorBoard, so don't worry about that. You shouldn't receive that error. Okay, so that's what import OS is. TensorFlow, we import TensorFlow as TF, pretty standard. We'll be using NumPy to feed in our data set, so that's important. And utils, again, is going to be our class, which we're going to work on and then import. So that's what this section is. So it's just going to try to open the current directory if it can, assuming I'm doing it on this computer and not another computer. These two sets of lines, if I had to say this sort of cell block for your Python notebook should be in any sort of Python notebook you work with, one being to change the current working directory, right, to this so that you can load image files or you can load utility functions from another script. But these two lines are very important. What these do is that every single time we make a change within class model, if you made a change in class model and you didn't have these two lines, what would happen is every single time you'd have to restart the kernel. What this does is these are actually reloading every single time the import of this utilities, right? What this means is that I can actually change this. So rather than saying pass, I can sort of print a statement, right? I can save that so that when I run it, it actually is updated with the change to the class, right? Again, because changing the kernel every single time is sort of laborious. And so these two lines are really your best friend. So I save that, print that, and again, it doesn't print because I changed it to pass. So that's what these make sense. I had mentioned in the last presentation that if you understand the concepts for one or two features, then the concepts will still apply for a million features. Think of it like this. If you understand gradient descent in one dimension with one feature, then the same rules and the same linear algebra and the same vectorization applies when we're talking about a million dimensions. There's absolutely no difference, right? So there's no point in using large data sets when we can use smaller data sets. So this is my data set. I'll show you exactly what it is. So what this line is just does is it prints an image on the page in Jupyter. So what this is I just import this image.picture1, which is in here. So it's pretty much just loading the image directly on the Python Jupyter notebook. So this is our data set. And right, simple, I know. So we have two features, x1 and x2, not in order. So x2, x1. And so what these sort of features represent are just inputs to a logic gate, okay? So if we have x1, the first feature, second feature, third feature, fourth feature. So x1 has 0, 1, 0, 1. The second feature is 0, 0, 1, 1. So both of these features or both of these inputs are just being fed into a logic gate, okay? And this just goes to show if I have this feature 1 and x2, what would an OR gate return given these two features, okay? So OR just says, are either of these inputs true? Yes or no? 1 or 0. So are either of these true? No. Are either of these a 1? Yes. Are either of these a 1? Yes. Are either of these a 1 or this or this? Yes, it is. At least one of them is true, right? So they all pass in as true or false here. So we can see how what this OR gate does exactly. This is the exclusive OR. So it does the exact same thing that OR does with the exclusion of the AND statement, right? So this last feature, for example, is fed a 1, and the OR gate returns true. So the exclusive OR says, is it an AND statement? It is? Okay, so it's not exclusively OR, right? So this will turn a 0. So pretty much what this is saying, if we were to look at a high-level representation of at least how a human understands it, is, well, is either feature a 1? Yes? Okay, pass in a 1. Are either of them only a 1? This one and this one? No, pass in 0. And then not XOR just takes the negative complement of not XOR. So 0 becomes 1, 1 becomes 0, 1 becomes 0, 0 becomes 1. So looking at, again, a higher, a look at this from a higher end view, bird's eye view, what exactly are we doing? Well, if what a not XOR in fact is doing is, are either of the statements or features the same? Yes. Are either of them the same? Yes. Okay. So pretty much what this label, again, this will become our label. What it in fact doing is, it is showing if either feature, if both features are the same. Okay. If this just was an AND statement instead of a not XOR, then it would only return true for this one, but not XOR will return true when they're both 0 and return true if they're both 1s. Okay. So this is our data set. Okay. So with that, we're going to minimize that a little bit, and we're going to start importing our data. Okay. So there's no there is no one-line statement to import all our data with 760 features and 10,000 training examples. So we'll have to do everything from scratch because there's only 8, so we can do that. Okay. So how I like to structure all my Python notebooks is feeding input data, hyperparameters, and then model. Okay, and I have these in different cells because importing your data you only need to do once. Hyperparameters and your model, you sort of want to tweak hyperparameters and then refer to run in the model at the same time. So in our model we have an x and y. Okay, so our x's are here and our y's are here. So we want to feed them as NumPy arrays so that TensorFlow is very familiar with that our inputs will be 32-bit floats. So we want to input our features. I can't remember what the default is for. NumPy arrays. I think they're float 64. So I think TensorFlow likes when they're 32-bit floats. So we're just going to explicitly state them as the default data type. So what we have here is our 2 features. Okay, so we have 2 features for training examples, right? So in the first one, we'll use this. We'll do x2 as the first one. Okay, so we have 0, 0, 1, 1, and the second one is 0, 1, 0, 1. Okay, and then we have our labels. Okay, so we'll do the exact same thing. NumPy array. Pass that in as a data type, being the default float 32. And what will this look like? Right, so this will just be our 4 labels, and we want to keep them in the same order as this, so that when we pass in our data, or sorry, when we pass in the features and data, they match, right? So we want to make sure they're in order, 1, 0, 0, 1. Okay, so if we run this, it'll run fine, and we can just really look at what we're looking at and sort of right? Because we want to have a good understanding of exactly what we're working with. Okay, so x.shape here is 2 by 4. So we can sort of say that x.shape is, I always like this, to do this during any of my comments. It just makes it much easier to see exactly what my inputs look like. So what we have is 2 features by training examples, right? Okay, just so I know exactly the shapes of everything I'm working with, and I know what position they're in, right? So features are the zeroth index, and the first index is training example. So it's a 2 by 4 shape. Okay, so that makes sense. And that'll be used for later on, okay? So we've already developed our feature and we understand exactly why we're passing them in as float 32, so TensorFlow likes it, and exactly why they're in this order. We have a really good understanding of exactly what these features are relative to the labels because we went over it, right? It's nothing we don't understand now, okay? So with that, I think that's a pretty good introductory to our problem. Today we sort of went over exactly why the features and labels are what they are, what our problem is, and what we're trying to solve. So our model is going to develop the not XOR problem on its own, right? Right? As simple as it may be, you'll see that it takes quite a few training examples to actually approach this solution on its own. We also imported our data as NumPy arrays, and we actually understand the shape of our features and training examples. It's a 2x4 matrix. So with that, we'll see you guys next time.